Good morning. Today we are going to take up some more trigonometric identities. So the topic for today is trigonometric identities of half angles. Now let us first consider the identity for cos 2a. We know that cos 2a can be written in two different manners. One is cos squared 2 cos squared a minus 1, and cos 2a can also be written as 1 minus 2 sin squared a. Now this gives us 1 plus cos 2a equal to 2 cos squared a and 1 minus cos 2a equal to 2 sin squared a. Now in this, if we put a equal to 2a equal to x, that is a equal to x by 2, we get 1 plus cos x equal to 2 cos squared x by 2 and 1 minus cos x equal to 2 sin squared x by 2. This gives us cos squared x by 2 equal to 1 plus cos x upon 2 and sin squared x by 2 equal to 1 minus cos x over 2, and from here we get cos of x by 2 equal to plus minus square root of 1 plus cos x upon 2 and sin squared x by 2 equal to 1 minus plus minus square root of 1 minus cos x upon 2. Now these are the two values which we have. So it means that both cos as well as sin x by 2 depends upon the value of cos x. So either if cos x is given directly to us or you are given any other trigonometric function, we first find the value of cos x and using this we can find the value of corresponding cos x by 2 and sin x by 2. Now to decide, in order to decide the sign 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 taken up by cos x by 2 and sin x by 2, we have to know the quadrant to which x by 2 belongs. Now we will be given a question where the value of either cos x will be given directly or indirectly, and then we will be also given the quadrant to which x belongs. Now we have to know the quadrant to which x by 2 belongs, only then we will decide whether cos x by 2 would be positive or negative and sin x by 2 would be positive or negative. So now let us proceed to find the quadrant to which x by 2 belongs. Now first case 1 is that when x is in first quadrant. So when x is in first quadrant, what do we have? X lies between 0 and pi by 2, which implies and is implied by x by 2 would lie between 0 and pi by 4, which implies first half of first quadrant. Okay, now so whether it is first half of whatever, it is in the first quadrant, and since it is in the first quadrant, so both cos x by 2 and sin x by 2 will be positive. Okay. Now the second case is case 2, when x is in second quadrant. Then in that case we have x lies between pi by 2 and pi, which implies that you divide throughout by 2. You get pi by x by 2 lies between pi by 4 and pi by 2, which is the second half of first quadrant, which implies that now again both cos x by 2 and sin x by 2 will be positive. Now here in this case also we have both cos x by 2 and sin x by 2 are positive, and in this case also we have both cos x by 2 and sin x by 2 are positive. Now let's see what we get when x is in. Now next is case 3. We have case 3 is when x is in third quadrant. Now when x is in third quadrant, in that case x lies between pi and 3 pi by 2, which gives us x by 2 will lie between pi by 2 and 3 pi by 4, and which is the first half of second quadrant. Now second quadrant we have, it implies that cos x by 2 is negative and sin x by 2 is positive. Now case 4, so here we have, because in the second quadrant we have cos is negative and sin is positive, so here also we have this. Okay. Now case 4 is when x is in fourth quadrant. Now when x is in fourth quadrant, x lies between 3 pi by 2 and 2 pi, which implies that x by 2 will lie between 3 pi by 4 and pi, which is the second half of second quadrant. And so whatever it is in the second quadrant, and so cos x by 2 is negative and sin x by 2 is positive. And we quickly see it in the graph form if you have the xy plane. Okay. So what did we observe? That okay, now when the angle x is in the first quadrant, this is second, this is third, this is fourth. Okay, first quadrant, then x by 2 is in the, so this is when x lies in the first quadrant, x by 2 lies in the in between 0 and pi by 4, which is the first half of the first quadrant. This is x in first. When x is in second, then what do we have? It x by 2 lies between pi by 4 and pi by 2. So that is x by 2 is again in first. This is the second one. Now when you have x lies in the third quadrant, x by 2 lies in the first half, that is pi by 2 and 3 pi by 4, first half of the second quadrant. So we have x by 2 in second quadrant, and when x lies in the fourth quadrant, x by 2 lies in the second half, that is 3 pi, between 3 pi by 4 and pi of the second quadrant, and so we have, this is x by 2 in the second quadrant. So no matter where x lies, x by 2, it implies that x by 2 always lies in the first and second quadrants only. And since in the first and second quadrant sign is always positive, so it implies that sine x by 2 is always positive. This is the first conclusion which we get, and then the remaining, it depends, like when x is in the first and second quadrant, since x by 2 is in the first quadrant, cos x by 2 is always positive, whereas when x is in the third and fourth quadrant, x by 2 is in the second quadrant, and so cos x by 2 is negative. So the sign is decided in this manner, and the value is decided by the formula, and so we conclude that sine x by 2 is always positive 1 minus cos x upon 2, whereas cos x by 2 is square root of 1 plus cos x over 2 when this is the positive square root when x is in first or second quadrant. Now here you don't have to get confused. Here we are talking about the quadrant to which x lies, whereas here we are talking about the quadrant to which x by 2 lies. Okay, and so the value of cos x by 2, and cos x by 2 is minus square root of 1 minus cos x by 2 when x is in third or fourth quadrants, and accordingly we can find the value of tan x by 2. Also tan x by 2 will be simply sin x by 2 upon cos x by 2, and with this you can try out question number 7, 8 and the last three, the 8th, 9th and 10th question of the miscellaneous exercise. Thank you boys.